Okay, so today we're going to learn about literal equations. The first thing we want to do with this literal equation is we want to solve for x. So I like to underline or kind of highlight what variable that I'm working with or going for, so that I can kind of focus on that. From here, what I would do is if you want to get x or you want to solve for x, you want to get it all by itself. So you want to just undo the operations that are happening to x. So what's happening to x? Well, we're adding 2c. So I could get rid of 2c by subtracting it to both sides. When I do that, I'll get negative 3x equals negative 3 minus 2c. And I'm going to leave that because I have no clue what negative 3 minus 2c is. I just don't know what it is, so I'm going to leave it. Then I have this negative 3x. So now I'm going to divide by negative 3 because x is being multiplied. When I divide by negative 3, again, I don't know what that divided by negative 3 is, so I'm just going to leave it. And that is my answer. So it's like solving an equation, but as you go through and solving the equation, you just leave stuff because you don't know what it is. So you just kind of go through like normal. Let's try the next one. Okay, so this time I'm going to underline the a because that's what I'm solving for. And when you want to get a by itself, again, you want to just do the opposite operations. So what's happening to a? Well, it's being multiplied by 12 and being multiplied by m. So how do I undo multiplication? Well, I do division. So I'm going to divide both sides by 12 and m. And because these things are both happening at the same time, like the multiplication's happening at the same time, you can divide both of them at the same time also. So that would leave a equals 4 over 12m. And that would be your answer. You really, if you wanted to, could also call that 1 over 3m, because you could reduce this fraction, because you know how to reduce that fraction. And that would be our final answer. Our biggest thing here, though, is we want to look at a, try to think about how to get a by itself, and just go through those steps. Let's try another one. Now we have to solve for x, but there's two of them. Like if I wanted to underline this, we'd have one here and one here. So what we want to do is we really want to treat this like we've treated all the other problems that we had yesterday. We want to try to get all the variables to one side. So I'm going to subtract xg from both sides. So I can have all the x's on one side. So xg minus xg, well, that gives me 0. And then we'd have 4 there. And then this would be 2x minus xg. And that's plus 4. Well, now I'd subtract 4 and subtract 4, which would give me 2x minus xg equals negative 4. Now, at this step, you might go, well, what do I do here? And what you really need to do is you need to minus 2x and xg. You might go, oh, I have no clue what that is. Well, I just want to look at, what if we did know what that is? What if g was 2? Well, then we'd have, what if g was, let's say, 5? Well, if g was 5, then we'd say, oh, that's negative 3x. We're going to do the same thing here. We're going to just subtract these two things, which would be 2 minus g x. So we subtracted 2 and g. I don't know what that is, but we can write we're going to do 2 minus g, and then x is just going to sit on the outside. Well, then we could divide by 2 minus g on both sides. And the reason we could divide by g, like 2 minus g, is because once we find that answer, we can divide it. And this would just be my final answer. So just make sure, as you're doing these different types of problems, the biggest thing is you want to try to picture numbers if you need help to figure out what you're doing, because it's the same thing, just with variables. Let's try another one. Okay. So the first thing on this one is we want to get the b away from the a, so we'll subtract b from both sides. We'll get z minus b equals a, or m over a. Well, then what we'd want to do is we'd want to multiply by a to get it to the other side. So that's going to cancel out. Now we have a parentheses z minus b equals m, because we're multiplying it on each side. The next thing I want to do is I want to get a by itself. So what's happening to a? It's being multiplied by z minus b. So then I would divide z minus b on both sides. And I'd have a equals m over z minus b. And that would be my final answer. Let's try another one. This last example is kind of the hardest example you get because we have two a's and we have a fraction bar, so we have a whole bunch of different things going on. The first thing I'd want to do is get rid of the fraction bar. So to do that, what I would want to do is I would want to multiply a to both sides. So we're going to multiply a here and a here. That'd give me ag equals, these would cancel out, and get 1 plus 2a. Again, since we have an a on this side and a on this side, what I really want to do is get all the a's together. So I'm going to subtract 2a from both sides. That'll cancel out. We're going to have ag minus 2a equals 1. And again, this goes back to like we had before, where you're trying to subtract two things. We don't know what it is, but we can subtract them. So I can do g minus 2, and then that's going to have an a on the end, because when we can subtract g minus 2, we will. And then to undo that from both sides, we'll just divide by g minus 2, and we'll get a equals 1 over g minus 2. And that would be our final answer. So anytime that you like have this subtraction with two variables, just treat it like our 2 steps yesterday. Everything we're doing today is the same as our equations yesterday, just without numbers. We just do it with variables now. So try the different problems.